Today we're going to talk about dividing polynomials, which is going to be another way for us to find our factors. So we're going to go ahead and use the remainder theorem. The remainder theorem is going to tell us what our remainder is once we divide by some sort of linear expression. So here we're going to divide by x minus 4. If we were to set that x minus 4 equal to 0, we would get positive 4. That's going to be the value that we plug in for x to use the remainder theorem. So whatever value that we get for f of 4 is going to be the remainder for this division problem. Knowing what the remainder is going to save you time a little later on. So I've substituted 4 in for every x that I see in the function, and I'm just going to simplify. 64 minus 28 minus 6 is going to give us 30. Again, this is what the remainder will be when I divide this. So now let's look at how to divide using long division. There is a shortcut for this, but we're going to do it the long way so that we appreciate the shortcut. So first, when you look at your polynomial, you want to make sure that you have each term from biggest degree to smallest degree. If you're missing one of those terms, in this case, I'm missing an x squared term, I want to include a 0 for a coefficient. So I'm going to go ahead and write a rule off to the side. So because I'm missing this x squared term as an example, I have to put a 0 for a coefficient in front of the x squared. I'm basically just saying I have 0 x squared terms. When you do long division, you have to hold place value for any missing terms. You'll see why that's necessary in just a minute. So let's see how to divide this, and then I'll show you a little trick. So first, I just want to look at these first terms, and I want to ask myself, what can I multiply by x to get x cubed? Well, I can multiply x squared times x to get x cubed. It would be beneficial to line up those x squares. So just on your own paper, put the x squared term over the x squared term. It will help you in the long run. So now I'm going to multiply x squared times that entire linear divisor. X squared times x gives me that x to the third power. And then x squared times negative 4 gives me negative 4x squared. I have to subtract this whole thing. So I do like to use a different color here or something that helps me remember that I need to subtract both of those terms. X cubed minus x cubed is 0, but then here 0 minus a negative 4x squared needs to change to a positive 4x squared. So here's where I like to use a different color so I can show I'm changing this sign, and it helps me organize combining those like terms. So just like in regular long division, we want to go ahead and bring down the next term. So I'm going to bring down that negative 7x, and I'm going to start this process all over again. I'm going to ask myself, what times x is going to give me 4x squared? So 4 times 1 is going to give me 4, and x times x is going to give me x squared. So 4x times x is 4x squared, and then 4x times negative 4 is going to give me negative 16x. This is the step where you have to subtract the whole thing. So this is where I would suggest using a different color. When I subtract that whole thing, 4x squared minus 4x squared will cancel, but then that negative 16 will change to a positive 16 because minus negative 16 is adding 16x. So negative 7x plus 16x gives me 9x, and then I can go ahead and bring down that next negative 6, that next term. So this is the last time we're doing this. You know that you're done dividing when you have run out of variables. So I'll do the same thing. I'm asking myself, what can I multiply by x to get 9x? That's 9. 9 times x is 9x. And then 9 times negative 4 is negative 36. I need to subtract the entire expression. So 9 minus 9x is going to cancel out. And then that negative 6 plus 36 is going to give us 30. And we'll write this as the remainder over the divisor added to the rest of that polynomial. Notice how that matches our remainder from the remainder theorem. So although we divided this successfully, this answer is not a polynomial. And the reason that it's not a polynomial is because we have an x in the denominator in one of those terms. So it basically just means that whatever we divided by is not a factor of that x cubed minus 7x minus 6. So this is where the factor theorem comes in. When we get a remainder that is 0, it means that we found a factor. So we're going to look at an example of something that we know how to factor so that we can better understand what that factor theorem and remainder theorem means. So here I'm going to take this x squared minus 3x minus 4, and I'm going to use the remainder theorem with x minus 4 as my divisor. So if you were to set that divisor x minus 4 equal to 0, you'd add 4 to both sides and you'd get positive 4. You're going to use that to plug in 4 for every x that you see in that function. So you want to just simplify this using PEMDAS, so exponents will come first, and then you can subtract that 16 minus 12, which is 4, and 4 minus 4, which is 0. So this is the remainder. Finding 0 as a remainder is a good thing. It means that this x minus 4 is a factor. So we're going to go ahead and factor this like we already know how. So we'll look at that sign at the end for x squared minus 3x minus 4. That minus sign tells me that I have different signs. So x times x is x squared. I know that I'm going to have 4 times 1, which is 4, negative 4 plus 1, which is negative 3. So when I do long division for this question, I should find x plus 1 as my answer. So we'll go ahead and set this up here. Notice that you have x squared, x to the first, and then no x's. So we don't have to put any zeros for missing terms here. I'll go ahead and think about this. What can I multiply by x to get x squared, which is just x? So then I'll go ahead and multiply that x times everything on the outside, that divisor. X times x is x to the second. X times negative 4 is negative 4x. This is where my other color comes in handy. I'll go ahead and subtract the entire expression. So I'm putting that entire expression in parentheses, and I'm going to change that second sign. X squared minus x squared will cancel out, and negative 3 plus 4 will give us 1x. Then I'm just bringing down that last term, and I'm going to ask myself, what can I multiply by x to get x, which is just 1, and then I'll multiply that 1 times x and that 1 times negative 4, subtract the entire expression, the x's cancel out, and the negative 4 plus 4 cancels out. So because we get a 0 for our remainder, we can say that x plus 1 times x minus 4 is equivalent to x squared minus 3x minus 4. The factored form of this expression is x minus 4 times x plus 1. That's the same expression that we got when we factored this, the way that we know how to factor this. So even though we know how to factor a quadratic trinomial, the goal of dividing polynomials is to find all the real factors when you don't know how to factor, or you can't factor with any method that we know. So we're going to look at an example now where it looks like we could factor by grouping, but it doesn't factor by grouping. So we have to use long division here. So on your own, I want you to use the remainder theorem to determine if x minus 2 is a factor of this expression. And I also want you to practice long division with this question to see what's left over after you divide. Go ahead and pause the video here, try both, and come back when you're done. So just to show you little by little, we do end up getting 0 as a remainder, which means that we found a factor. So we're going to use long division here, not only to see what's left over after we divide, but to find out the other factor, to be able to factor this completely. So I've got the first step here. A trick is that you're going to start at the exponent that's 1 less than what you're dividing. So I'm starting with x to the second. And then I am going to figure out what I need to multiply by x to get 2x to the third, which is going to be 2x to the second. Then I'll subtract the entire expression. Remember that I need to change those signs. I'm telling you, if you use a different color, your life will be much easier. You combine like terms, negative 1x squared plus 4x squared gives me 3x squared. And then I'll bring down that negative 7 and do that process over again. My next term is going to have just an x in it. So 3x times x is what's going to give me 3x squared. 3x times negative 2 gives me 6x. And then I'll go ahead and subtract the entire expression. Remember that that changes the signs. So 3x minus 3x squared cancels out. And negative 7x plus 6x is going to give me negative 1x. I'll bring down the 2. Then I need to multiply by a negative 1 in order to get that negative x. When I multiply negative 1 times x, I get negative x. And then when I multiply negative 1 times negative 2, I get a positive 2. I need to subtract the entire expression, which is going to cancel out both of these, which shows that my remainder is 0. That negative is going to become negative x plus x, and that 2 minus 2 also gives you 0. Yay! So that means that I can write the factored form of this equation. X minus 2 times 2x squared plus 3x minus 1 is equivalent to that original x to the third expression. Now here you would want to check to see if you could continue factoring. Here you can't. I tried it. You end up getting decimals for your zeros. But your inevitable goal is to find all of the zeros of the polynomial functions. Here's another one for you to try without my help. So I want you to do the remainder theorem to figure out if x plus 4 is a factor, and then use long division to factor out that x plus 4 to see what's left. Pause it here, try it, and come back when you're done. So you should have gotten 0 as a remainder for the remainder theorem, which means that x plus 4 is a factor of that expression. Remember that you need to put in zeros where you're missing terms. So if you didn't put 0x to the third and 0x to the second in your dividend, go back and fix that and try it one more time. Working with those zeros is just multiplication, division, addition, and subtraction of 0 terms. So you might want to pause here and check all of that work to make sure that you worked with those zeros properly. So because you have 0x cubed, 0x squared, and 0x, you do not need to write that as one of your factors. You can simply write your factored form as x plus 4 times 8x to the fourth plus 5. So eventually this process is going to help us sketch a picture of this graph. And if I were to set that 8x to the fourth plus 5 equal to 0, I'd end up getting imaginary solutions, which tells me I can't factor anymore. And if I set x plus 4 equal to 0, I still know that this is a degree 5 function, so it goes down on the left and up on the right. And that x plus 4 equals 0 gives me the x value of negative 4, so I know that that passes through because it has multiplicity 1. So eventually we're going to end up using this to find all the zeros of a function and graph that function. You should struggle with this. If this seems difficult, it's because it is. Long division is something that you did in like 3rd grade. So now you're doing long division with variables, and you're gonna need some practice. Remember that when your brain is hurting, that's how you know you're learning. Have a great day. We'll see you next time.